Welcome everyone, bit of a different video for today. I'm going to be talking about some of the arguments for the view that the universe had a beginning. This issue sometimes comes up in relation to cosmological arguments for the existence of God, right? But they're of interest more broadly as well. And I'm going to focus on some of the more philosophical and mathematical arguments for this conclusion, not more scientific ones. Cosmology, thermodynamics, and related considerations themselves might warrant the belief that the past is finite or infinite. And that's surely worth considering, but it's not my target here. As an aside, my admittedly non-expert perception on that is that, scientifically, the most promising cosmological models include a finite past, but, well, it still somewhat remains an open question. But some contend, independently of these sorts of issues, that in some sense the past cannot be eternal, right? Arguments made to this effect involve claims that an eternal past violates some independently plausible principle, like be it mathematical, metaphysical, or something else. And these arguments are going to be the target of my discussion here. And the conclusion I'm going to reach is largely negative. The arguments typically made fall short of demonstrating that the past is, let alone must be, finite. Before I get into some of the arguments, one quick clarification. The thesis under consideration is that the universe is past eternal, right? And by that I mean, to put it one way, that the past includes an infinite sequence of non-degenerate temporal intervals of equal duration, infinitely many days, for example, where a degenerate temporal interval is a temporal interval, an interval of time of zero duration, right? So on this thesis, there are infinitely many days, seconds, milliseconds, or whatever that preceded the present in time. To be clear, I'm not arguing that this thesis is true. Rather, my contention is that the arguments with which I'm familiar are insufficient to establish that as false and that the universe is finite toward the past. Two more preliminary remarks. First, I'm conscious of the fact that my discussion here, as well as that in the relevant philosophical literature, typically takes for granted certain features about time which are potentially false. And I mean, this is a more fundamental issue outside the scope of this video. At any rate, I do not think that I make assumptions regarding time that are not typically made by those forwarding the arguments under consideration. If you prefer, take my conclusions as conditional on the assumption that time is roughly as it's assumed to be. Second, I'm going to avoid talking about tensed and tenseless time and variants of each. So some arguments may assume some account, like tense theories. And so these arguments are going to be unsound if the assumed account is false. But my criticisms are going to be neutral in this regard. All right, since I think the arguments are unsound, even if the assumed theory of time is correct. I mean, that said, if you're unfamiliar, I would recommend learning about these notions in the philosophy of time. All right, so with that out of the way, the first argument I'll be considering is the Grim Reaper argument. This argument is adapted from a paradox discussed by J.A. Bernadetti. There is mention of it also in David Chalmers' Conceivability and Possibility, as well as Robert Kuhn's A New Kalam argument, Revenge of the Grim Reaper, and that's going to be the target of my discussion here. The basic structure of the argument is this. If it's possible that the universe is past eternal, then Grim Reaper style scenarios are possible. It's not, Grim Reaper style scenarios are not possible. Hence, it's not possible that the universe is past eternal. All right, so what is a Grim Reaper style scenario? Well, it's like this. Suppose there are infinitely many Grim Reapers, each of them given a similar task. One is given the following task, which we suppose it carries out if it's possible for it to do so. At precisely 1 minute past noon, if a particular person, Fred, is still alive, kill him, right? And there's another Grim Reaper with the same instruction, except that it is for 30 seconds past noon, another for 15 seconds past noon, 7.5 seconds past noon, and so on, right? Such that there's a Grim Reaper with the same instruction for 1/2 to the n minutes after noon for every non-negative integer n. Right? So there's going to be infinitely many, and they get more compact as it gets closer to noon. In this scenario, however, it seems both that Fred cannot be killed, but also that he cannot survive. Right? So we have some inconsistency here. In support of the latter, were he to be alive at 12:01, the last Grim Reaper would surely kill him, because we're supposing it's possible for a Grim Reaper to kill him, and he's alive at that time. And that's the instruction that it's given. But in support of the former, if a Grim Reaper kills him at some time, right, so 1/2 to the n minutes after noon for some non-negative integer n, then he would have been killed by the Grim Reaper prior to it in the sequence, since Fred would have still been alive at 1/2 to the n plus 1 minutes after noon. Accordingly, any particular Grim Reaper can kill Fred only if the prior Grim Reaper, in fact, all prior Grim Reapers, failed to satisfy their instruction. And that violates the thought experiment. So the argument goes, Grim Reaper style scenarios are impossible. So, interesting thought experiment. So there are a few responses that we might have to this sort of argument. We might try to make sense of the idea that Fred is killed, but not by any individual Grim Reaper. This is kind of strange. I'm not going to defend this view or others like it here, and we'll just grant that Fred is killed by a Grim Reaper if he is killed at all. I will grant, and in fact do accept, that the described scenario violates plausibly true mathematical and causal principles. However, I do not grant the more general argument that against the universe being past eternal. So supposing that these principles are necessary, we can simply accept that Grim Reaper style scenarios are not in that sense possible, but without granting that they would be possible if the universe can be past eternal, right? So to speak on Kuhn's formulation of the argument, my response involves a denial of the patchwork principle, which he borrows from David Lewis. This principle is a bit technical, and I'm going to leave aside detailed discussion of it here. But my point is that the collective task, right, of all the Grim Reapers satisfying their instruction is not, in fact, satisfiable by a sequence of Grim Reapers which has no first member, even if positing any individual Grim Reaper entails no similar absurdity. This is due to the fact that in positing any individual Grim Reaper, it is not required that said Grim Reaper comprises part of a larger sequence or structure, which is not possibly realized. This doesn't entail, however, that the resulting structure is possible, contra the patchwork principle. So if we therefore reject, as I do, the inference from the possibility of the universe being past eternal to the possibility of Grim Reaper style scenarios, then the argument provides us no good reason to accept the conclusion that the universe is not or cannot be past eternal. So to reiterate, the general point is that I'm willing to grant that Grim Reaper style scenarios are in some sense not possible, but not grant that time being infinitely divisible or infinitely extended in the way described entails that they would be possible. Just because time might be infinitely divisible or infinitely extended in that way doesn't entail that just anything can happen across the divisions, including Grim Reaper style scenarios. So a more complete explanation of my response here would involve discussing the patchwork principle more directly. I actually think it admits to a variety of counterexamples, but I'm going to leave that aside here. Similar alleged paradox, that the Grimm messenger paradox, has effectively the same structure as this one. So writing a number on the paper in the Grimm messenger case is the parallel to killing Fred in the Grim Reaper case, and passing the envelope or the paper is the parallel to doing nothing. So accordingly, my response to the Grim Reaper argument can, mutatis mutandis, be applied equally to the Grim messenger case. This can be said also for the Gong-Peel paradox, and I suspect other variations as well. I'll add, note that we can construct effectively the same paradox without supposing an infinite past. So imagine instead you have in front of you an infinitely large object, which has infinitely many light bulbs set up in a line. And for each light bulb, it is on only if none of the light bulbs to its left are on, right? We can straightforwardly show in the same way that if any light bulb is on, then there are light bulbs to its left, which do not satisfy the criterion. But if no light bulbs are on, then no light bulb has satisfied the criterion, right? And therefore, this is not a possible object, since it cannot be such that all of its parts satisfy the aforementioned criterion. But this is the conclusion, though, right? Not that you cannot have infinitely large objects, right? If all the light bulbs were off, or they were such that they followed some pattern that was possibly realized by an object like this, then no absurdity follows, to my knowledge, right? If the absurdity is generated by the infinitely large object alone, then why does the argument seem to proceed only by assuming that it's constructed in this impossible way? If the infinite size alone generated the absurdity, then some specific criterion, right, for the state of its parts should be otiose in an argument demonstrating that absurdity. But it's not, right? Similarly, in the Grim Reaper case, the Grim Reapers together comprise a sequence, or an object for those not mereologically composed, which cannot be such that all of its components satisfy the given criterion. Merely positing infinitely many objects, or infinitely moments of time, or infinite divisions of time, to my knowledge, entails no similar absurdity. I mean, if it does, it's not because of any sort of Grim Reaper style argument. Moving on, another argument that is sometimes used against the universe being past eternal involves a thought experiment called Hilbert's Hotel. And we can frame the argument similarly as a modus tollens as follows. If the universe can be past eternal, then Hilbert's Hotel style scenarios are possible. Hilbert's Hotel style scenarios are not possible. Hence, the universe cannot be past eternal. So what then is a Hilbert's Hotel style scenario? Well, this thought experiment was originally developed by German mathematician David Hilbert. So we're to imagine a hotel with infinitely many rooms, right? And there's one guest for every room. When new visitors arrive to a full hotel, they need not be turned away. Right? We can make room for them even though the hotel is already full, because we can move the guests from room 1 into room 2, the guests from room 2 into room 3, and so on, such that the guest from room n was moved to the room n+1. And now room 1 is vacant. It's available for the new guests, and they move in without issue. And we can even suppose that infinitely many visitors can arrive at once to a full hotel, and they can all be accommodated, right? Because here, and there's a few ways to do this, of course, but for one, we can move the guests in room 1 to room 2, room 2 to room 4, room 3 to room 6, and so on, such that the guest from room n was moved to room 2n, right? Well, that'll put all the previous guests into even numbered rooms, leaving all the odd numbered rooms vacant. And that will be more than enough for the new guests. Surely, however, a full hotel finite or otherwise, cannot accommodate more guests, right? It's full, let alone infinitely more. At least that's how the argument goes. On the contrary, though, I don't think this result is actually absurd. This sort of mathematical behavior is well understood. The appearance of absurdity, I think, stems from the fact that certain results involving infinities are surprising. And in this case, we tend to use heuristics developed when thinking about finite hotels and other finite things. And we use those heuristics to draw conclusions here about an infinite hotel. But just as heuristics about finite sets might go wrong when extended to the infinite case, they can go wrong here as well. Right? I mean, there's a reasonable heuristic for the finite case of sets that a proper subset of a set is going to be strictly smaller than that original set. But that's not true for infinite sets, for example. So someone might respond on this point, well, that might be so, but the realization of such a hotel or these operations performed on it, whatever, that violates some other principle to which I hold. Well, what is it? I mean, I've yet to see such a principle that is both well motivated and is not something like a physical law. Right? Again, some physical limitation on the realization of such a hotel is uninteresting here because these arguments are, again, intended to be largely independent of what the world is like in that regard. Okay. If there were such a principle, however, the response remains open to deny that such a hotel would be possible in the relevant sense, even if the universe is past eternal, right? I mean, this reply will be available in general when considering these sorts of thought experiments. I mean, after all, so far as the arguments are concerned, I mean, no absurdity follows merely from the posit of a past eternal universe. And so we can posit such a universe without affirming that therefore these scenarios are possible. I mean, if they are in fact impossible in the relevant sense. If they can't obtain, then, well, they can't obtain. But this says little about whether the universe can be past eternal, unless commitment to the possibility that the universe is past eternal, in fact, commits us to the possibility of these absurd hypotheticals. For the cases discussed, either it does not so commit us or they are not genuinely absurd. So for more on Hilbert's hotel, see, for example, Lewis Wingrover's difficulties with William Lane Craig's arguments for finitism. And for another discussion of a different vertical paradox, which has been used to argue against past eternal universe, see, for example, Graham Oppy's From the Tristram Shandy Paradox to the Christmas Shandy Paradox. Okay. More can be said, of course, on these and related arguments, but I'm not going to say it here. Instead, I'm going to move on to another sort of argument which can be expressed succinctly as follows. If the universe is possibly past eternal, then it is possible to traverse an actually infinite duration of time. It is not possible to traverse an actually infinite duration of time. Hence, the universe is not possibly past eternal. Is this argument any good? So, I mean, we can imagine someone who starts counting, for example, the natural numbers, 1, 2, 3, 4, and so on. And he counts as having traversed an infinite if at some time he completes his count. Supposing that completing a count of this sort requires there to be a final and greatest number in said count, it cannot be completed, since any such stopping point leaves greater numbers left uncounted. If a past eternal universe had to be like this, right, that someone could complete a count of that sort, then I think we could grant that the universe could not be past eternal. But this is not what a past eternal universe has to be like. In fact, I would think it's something we can rule out on a past eternal universe. Anyone who starts counting on a particular day would not finish their count in the present. or on any day, if it's an infinite count like that. But anyone who had always been counting, well, they might finish that count in the present. So it's not required that there is someday, for example, the start of a count, which is infinitely separated from any other in time. By analogy, no natural number is infinitely separated from any other. The difference between any two natural numbers is always another natural number. But the set of natural numbers is still infinite in size, right? Similarly, in a past eternal universe, no past day is infinitely separated in time from the present or any other day. Yet the set of past days, right, is infinite in size. So if that's what we mean by traversing the infinite, if that's what the problem is supposed to be, well, then that's just false. We don't suppose that we could traverse an infinite in that way if the past is infinite. But how else are we to understand traversing the infinite? It might mean something like completing a sequence with infinitely many elements. But to me, this seems either to incorrectly suppose, again, that the sequence must have a first member, or it's just another statement of the conclusion that the universe cannot be past eternal. I don't see what's being added here by this premise. So absent some additional reason to accept the premise, as far as I'm concerned, the argument lacks any force. Of course, a proponent of this sort of argument is free to provide such a reason. And to move on, there is a related sort of argument which might purport to do just this. And it can be summarized as follows. If the universe is possibly past eternal, then it is possible to complete an actually infinite series by successive addition. It is not possible to complete an actually infinite series by successive addition. Hence, the universe is not possibly past eternal. This sort of inference, although with more detail, has been forwarded by William Lane Craig, but it has some history, including Al-Ghazali in Moderation and Belief, and Kant in his first antinomy, among others. The notion of successive addition can be understood, at least informally, in the following way. Right? Things are, in this case, days are added one after the other to the extent of history. So this is, really easily understood in the finite case. There have been 3 days, then there have been 4 days after another day elapsed, then there have been 5 days. Days are successively added to the extent of history. Now, if the infinite case did require that the number of days is at any point finite in the same way, well, then absurdity will surely follow, right? Because that would require that there's some first day, right? But as discussed previously, this isn't right? On any day, there have been infinitely many days prior to it, and yet days occur one after the next. Consider, by analogy, the set of integers, including negative integers, equal to or less than some integer n, right? We can successively add greater integers to the set, or to form a new set, which has members that the previous set didn't have, right? I can add n plus 1 to this set, for example, then n plus 2, then n plus 3, forming sets which have new members. We're successively adding new numbers to the set, right? Well, strictly speaking, forming new sets, if that's how we're thinking about it, but it doesn't matter. That seems perfectly fine as a case of successive addition. And we can suppose that this is how each member is added, each number is added. What's wrong with that, right? And similarly for the case of an eternal past, right? Days are successively added to the extent of time, even though there's always been infinitely many days. For each day, it was such that it was successfully added to a set of days which didn't include it. Right? And so I don't see why an infinite cannot be completed in this way by successive addition, right? Because remember, in the integer case, in the number analogy, when supposing we're at the point where n is added, well, the set is infinite. If we've always been counting, say, we've added n, we've completed an infinite set by successive addition. Of course, given that we've always been counting, we've always completed an infinite set by successive addition, but I don't see the absurdity in that. So against this sort of response, Jacobus Erasmus has provided a supplementary argument for thinking that if a count which begins can't end, right, then a count which didn't begin can't end either. So we're to imagine Jones, an eternal being who has recorded all of his life up to a certain point. Well, we'll just say that's the present. And now he starts playing back the recording in reverse order, right? So it starts playing from the present, moving backwards. And the argument goes like this: if the universe is possibly past eternal, then possibly Jones could record and watch the entire film. It's not possible that Jones could record and watch the entire film. Hence, the universe is not possibly past eternal. However, as Wes Morrison points out in Infinity, Time, and Successive Addition, the second premise is ambiguous. If it means something like there's not going to be any day on which Jones completes watching the film, right? Then the second premise will be true, but not the first premise. Again, we're not supposing that someone can say start counting the natural numbers and then complete that count on some day, right? That's never been supposed on the hypothesis that the universe is past eternal. It's not entailed by it. We're supposing that it's false. And so if this is what the second premise means, we're not going to grant the first. However, if the second premise means something like, for each frame, there will be a time at which that frame is viewed, well, then the second premise is just false, because that is something, assuming the universe is future eternal, and he does watch the film, each frame is such that there's some day on which it will be viewed, right? Just in the same way that someone counting up the natural numbers, there is some day on which each natural number will be counted. That's what it would take for the universe to be future eternal and someone to count all of the natural numbers. This result may seem counterintuitive, and it may violate certain heuristics that develop for thinking about the successive addition in the finite case. But the argument, to my knowledge, reveals no mathematical or metaphysical absurdity in the possibility of a past eternal universe. For more in favor of this line of argument, consider, for example, the discussion by William Lane Craig and James Sinclair in the Blackwell Compendium to Natural Theology, as well as Jacobus Erasmus's The Column Cosmological Argument, a Reassessment. For more against it, see the aforementioned article from Wes Morrison. For a critical focus on Kant's version, see Jonathan Bennett's The Age and Size of the Universe. A more complete discussion is beyond the scope of this video, but nothing in the relevant literature, to my knowledge, undermines my response to the argument. I'll turn now to another sort of argument, which has also been forwarded by William Lane Craig, and we can summarize it as follows. If the universe is possibly past eternal, then possibly there is someone who counts all the negative integers and completes that task whenever the conditions are sufficient for the completion of that task. Okay. It is not possible that there is someone who counts all the negative integers and completes that task whenever the conditions are sufficient for the completion of that task. Hence, the universe is not possibly past eternal. That second premise might be supported by noting that if the count is finished on some day, well, then the conditions were sufficient for the completion of the count on the previous day, since there were as well infinitely many days terminating in that day, right? But the same conclusion applies to that day, the day before, and all days, right? Suggesting that it couldn't be completed at all. If the first premise is right, then the universe therefore cannot be past eternal. A similar variant of this argument might be made in the following way. If the universe is possibly past eternal, then it is possible that there is someone who counts all of the negative integers, and there is an explanation for why the count terminates on one day rather than any other. It is not possible that there is someone who counts all the negative integers, and there's an explanation for why the count terminates on one day rather than any other. Hence, the universe is not possibly past eternal. Now, on the first version of the argument, I reject the first premise as well as the support that there being infinitely many past days is sufficient for the completion of a particular count. So after all, if the particular count in question is such that -10 is counted today, then the conditions for the completion of this count are not met, right? Even if we know that there are infinitely many days past. I mean, consider a finite case, right? You suppose I was counting down from 100, and we ask whether the conditions are sufficient for the completion of that task today. Well, there have been 100 days prior, but depending on the count that I'm in fact engaged in, right, and where I am in that count relative to some present, will determine whether the conditions are sufficient for the completion of that count. If I'd counted -10 today, even if the count was finite, then the conditions are not met. And I think we can say the same in the infinite case. If we say only that some count of the sort has occurred, then for all we know, it might terminate on any day. Once we know more about the count, right, i.e. which numbers are counted on which days, it doesn't remain an open question on which day the conditions are met for the completion of that count. Accordingly, on the second version of the argument, the second premise is false. It is enough to say that the count terminated today because -1 was counted yesterday, -2 the day before, and so forth. These facts rule out all other days, but today is days on which this particular count can be completed. I mean, what more is required of such an explanation? If we nevertheless do require some further explanation not satisfied in this way, I want to know what sort of explanation is required and why it is required. After all, the situation seems well enough explained to me. Other arguments sometimes made informally are frequently less well-formed than those discussed here and are often formulated on the basis of unclear intuitions. So for example, someone might say something like, if the universe is past eternal, then you never arrive at the present. You never get to the present. If this is meant like very charitably as either the argument from the impossibility of traversing an infinite or as the argument from the impossibility of forming an actual infinite by successive addition, then my responses to those arguments suffice, right? If something else is meant, then clarification was needed, at least for me. Some also say things like, well, the past can't be actually infinite because an infinite cannot have a point at which it terminates. This is, of course, false. The negative integers terminate at -1, for example. It's easy to generate further examples where you can have sequences with first and last members, yet are still infinite in size. There's no issue at all with an infinite having a point at which it terminates, so long as it's a sequence or a set that just has infinitely many members. That's entirely consistent. In any case, many of the other arguments people might make here are charitably interpreted as versions of the arguments that I've discussed, or at least such that my responses apply equally to them. That said, this is, of course, not a comprehensive survey, and surely there are more arguments that have or or might be made. Additionally, there's more that might be said on the arguments I've discussed, but nevertheless, I think that my remarks seriously undermine the arguments which are most frequently made for the conclusion that the universe cannot be past eternal, which suffices for the negative conclusion I noted at the outset. So I'll end it there. Feel free to leave any comments on the points I've made as well. If you want to support more creation of content like this and would like some additional perks, please consider contributing to the channel on Patreon at patreon.com/friction. Much thanks to the current patrons, NinjaBem, Mars Bars, and Riz. So among other things, patrons get early access to videos like this and all the interviews that go eventually to the channel. For everyone else, thanks for watching, subscribing, and I'll see you in the next one.